So first question in the short answer section, we've got parallel metal plates. These are positive up here. These are negative down here. Separated by a distance of that, so that's D, and have a potential difference of 1,000 volts applied across them. Magnitude of the electric field strength, E equals V over D. This is an easy one for 1 mark. It's 1,000 over the distance separating plates is 5 by 10 to the negative 3 metres, which is equal to 2 by 10 to the power of 5 volts per metre. I don't know why I wrote a W. We'll just scratch that. 2 by 10 to the 5 volts per metre. Next part. Calculate the magnitude of the electrostatic force acting on an electron between the plates. So the electron, we need to know the charge on an electron, and that's equal to 1.602 by 10 to the negative 19 coulombs. We also know that the electric field from the previous question was 2 by 10 to the 5. Now, if you got the first part of that one wrong, but you utilised it properly here, you will get the marks, and that's volts per metre. So force equals QE, which is equal to 1.602 by 10 to the negative 19 times by 2 by 10 to the 5. Chuck that in your calculator and you get 3.2 by 10 to the power of negative 14 newtons for 2 marks. So getting the right answers 1 mark, and getting this first bit, putting your numbers in, is another mark. Righto, moving on. Starting to get a little bit trickier. We are going to be firing a beam of electrons with this velocity, 3 by 10 to the 6, between the plates. A magnetic field is applied between the plates sufficient to cancel the force on the electron beam due to the electric field. So what's happening here is our electric field, if this is a beam of electrons, as the electrons are going through here, they're going to be attracted towards the positive and away from the negative. So we are going to try and apply a force to counterbalance that to bring it back down again. So that means that the force due to the electric field, force electric must be equal to the force magnetic. So we know that V equals 3 by 10 to the 6 metres per second. Go back to my red pen. We want to know the magnetic field. We also know that the electric field is 2 by 10 to the 5 volts per metre. The force, we don't know. They're going to cancel out anyway. So we end up with force due to the electric field is equal to QE. The force due to the magnetic field is equal to QVB. So that means that QE must equal QVB. The charges cancel out, and we're left with 2 by 10 to the 5. 2 by 10 to the 5 must equal our velocity, 3 by 10 to the 6 times by the magnetic field, dividing both sides by 3 by 10 to the 6, and you get your magnetic field must be 0.07 Tesla. But we want to know the magnitude and the direction. Okay, so using your right-hand slap rule once again, to get that to work, we want the force, so you slap down the page. Now, because the electrons are going across the page to the right, that means a positive current flow must be to the left, so the thumb goes to the left, and we want it to go down, so therefore your fingers are pointing into the page. So that's your direction, is into the page.